In section 5.3, congruent angles associated with parallel lines, we're going to be given several new theorems that, when presented with parallel lines, will help us come to various conclusions and help us draw some context from these parallel lines. But first, we're going to start with a postulate. Let's say that I have a line. And then I simply just have a point off of the line. If you think about it, there's only one line that can go through this point but still be parallel to the blue line. So that's what the first postulate says. Through a point not on a line, there is exactly one parallel line to that given line. The first of our many theorems that we're going to take a look at today is Theorem 37. If two parallel lines are cut by a transversal, each pair of alternate interior angles are congruent. So in this case, if we look at this diagram and we say that line A is parallel to line B, then this angle would be congruent to this angle, as this angle would be congruent to that angle. Now, based on this theorem, let's think about the next one. Let's just say that we label the following as this angle is x. This angle right here would have to be 180 minus x, since they're supplementary to each other. This angle would have to be x, since they're vertical angles. And then this angle in here would have to be 180 minus x. And based on Theorem 37, that alternate interior angles are congruent. This would have to be x, 180 minus x, and 180 minus x as well. Now, based on that, if I randomly pick any angle and I try to find I randomly pick another angle, so if I pick this one to begin with, those two angles would be supplementary. Well, if I didn't pick this one, let's say I picked this one, well, that angle is supplementary. Well, again, let's just keep going around. If I didn't select that angle, and I instead selected this one, that would be congruent. Now think of the next four. If I chose this one, or this one, or this one, or that one, the angle will either be congruent or supplementary. So that brings us to Theorem 38. If two parallel lines are cut by a transversal, then any pair of the angles formed are either congruent or supplementary. Let's look at this diagram again. If I still think about Theorem 37, that the alternate interior angles are congruent if we have parallel lines. If I know that this is congruent to this angle, the alternate interior angles, we already labeled these. This is 180 minus x, as would this be. But then if we look up here, you'll also notice that's 180 degrees, and then this is 180 degrees. Therefore, if two parallel lines are cut by a transversal, each pair of alternate exterior angles will also be congruent. And finally, if we look at this diagram, you'll notice here to here is congruent, here to here. If you recall what those are corresponding angles, which is Theorem 40. If two parallel lines are cut by a transversal, each pair of corresponding angles are congruent. All right, what other things can we conclude from this diagram? Well, what if we take a look at this angle and this angle? If you add those two together, you would get 180 degrees. the x's would cancel out and would be 180. If you look at this angle in correspondence with this angle, again, the x's would cancel out and you'd be left with 180. So what can we conclude? Well, that if we have a pair of angles that are exterior on the same side, they're going to be supplementary. We can also conclude the same thing with on the same side of the transversal with interior angles. And finally, our last two theorems. Theorem 43 says, in a plane, if a line is perpendicular to one of the two parallel lines, it is perpendicular to the other. So let's think about this. If we have two parallel lines, that means that each of the slopes would be the same. So we'll leave these as A over B. And if we know that one of the lines is perpendicular to a line, or to the transversal, it would have to be the opposite and the reciprocal, negative B over A. Well, since this is opposite reciprocal to this one, you'll notice it will also then be the opposite reciprocal to the other parallel line. And finally, theorem 44, if two lines are parallel to a third line, then they are parallel to each other. And this is kind of the basic transitive property of parallel lines. Your book does allow you to use shorthand, and so will I, for a lot of these theorems, since there are quite a few of them. For theorem 37, what you can do to shorthand this is you can make the parallel line sign. Parallel lines imply alternate interior angles congruent. So it's one way you can shorthand 37. And basically, that's going to follow suit with quite a few of the other ones. If you look at theorem 39, again, you can just do parallel lines imply alternate exterior angles congruent. Again, parallel lines imply corresponding angles congruent. All right, let's look at a few examples. The first one is number 15 from your book. Given line FH is parallel to line JM, and angle 1 is congruent to angle 2, and line segment FH is congruent to JM, we want to prove that GJ is congruent to HK. So let's start by taking a look at what we are given. So we know the parallel lines, and those are marked for us already in here. We know that angle 1 is congruent to angle 2, so let's mark that. And we know that FH is congruent to JM. Now let's look at what we're trying to prove. We're trying to prove that GJ is congruent to HK. Now if you kind of look and see, they overlap at line segment HJ. And then if I look at what's left over, you see this leftover segment right here and this leftover segment right here are part of this triangle here and this triangle here. So my best bet would be to try to prove those two triangles congruent. So how are we going to do that? Well, we have a good start because we're given one pair of congruent sides. And if we look at it, we can pretty easily prove that this angle right here will be congruent to this angle right here, since we know that 1 and 2 are congruent because those are angles are already supplementary to congruent angles, so we should be able to prove them congruent. So let's do that real quickly. Again, what I'm going to do is I'm going to prove that the two angles are supplementary, and then I'm going to then prove that the angles themselves are congruent based on the supplementary theorems that we talked about in very early on chapters. Now looking at the diagram, I have a pair of sides and a pair of angles. Now I need to figure out what the best thing would be to do. Do I prove the sides congruence? Is there anything to lead me there? Or do I try to prove the angles congruent? Our best bet would be to prove the angles congruent, since they kind of lie on parallel lines already. If we extend the parallel lines a little bit, and we look strictly at the parallel lines and the transversal, you'll notice that the angles that we're looking for are alternate exterior angles. So they themselves are congruent since they lie on the parallel lines. And using one of the theorems today, we can prove that angle GHF is congruent to angle FJM, again, because parallel lines imply alternate exterior angles. What this then does is this proves the triangle's congruent based on angle side angle. And once I establish those congruent triangles, I can then use CPCTC to prove that GH is congruent to JK, and then I'll use the addition property then to extend it to get to our conclusion. The second example we'll take a look at is another proof. We're given that CY is congruent to AY and line segment YZ is parallel to line CA. We're trying to prove that YZ bisects angle AYB. So again, let's look at what we have and where we're going. So if we know that CY is congruent to AY, and we know that YZ is parallel to CA, and we're trying to figure out that's a bisection line right there. To bisect it, that means that those two angles in there will have to be congruent. So again, we're trying to get those angles to be congruent. So let's take a look at what we have and how it might help. Well, since we have this, if you look on the side right here, two congruent sides imply congruent angles. So right away we can say that angle C is congruent to angle CAY. Now that really doesn't quite help with proving congruent triangles, so let's take a look at the parallel lines and see how that might help. Again, let's see if we extend the parallel lines and then maybe take a look at it out of context or out of the diagram. If I have C here, A here, Y here, and Z here, and we know that connects right here because we're looking for congruency right there, this line can be a transversal. And knowing transversals, we know that this angle and this angle, alternate interior angles, will be congruent. So then I can say that those two lines are going to then be, or two angles will be congruent. You might also see that the parallel lines here and here are not only cut by the transversal AY, they're also cut by the transversal CB. And if you look at that transversal, you'll notice that we have already established an angle here, but then that would be congruent to angle CYB based on same or corresponding angles. So we can say that those angles will be congruent. Now, if you look back at our diagram, we've kind of marked it already that this angle is congruent to this angle is congruent to this, and this angle is congruent to that. Now all that's left to say is that this angle and this angle will be congruent, kind of based on the transitive property, And once we establish that, then we've indeed established the bisection of that angle. The last example we're going to look at is called a Crookes problem. And what you have here is you are given that these two lines are parallel, and you want to find this angle that is kind of wedged in between these crooked lines between these. And you're only given minimum information about some of the other angles. Well, what you can do, because based on the first postulate, is we can draw a parallel line through the point at which those lines intersect, because there is exactly one parallel line through that point. Once that point is established, what you know then is that this angle is alternate interior to this angle, so they're going to be congruent. So this part of the angle is 40 degrees. Then if you look at the top, you'll notice that this right here is supplementary, therefore it has to be 80 degrees. And again, this angle and this angle are going to be supplementary, so this angle is 80 degrees. And then now you've established the full angle, which is the 80 degrees plus the 40 degrees. Therefore, the measurement of angle 1 equals 120 degrees.